Sorry. Yeah, it's a pleasure to invite Dr. Kamir Ricketts to speak with us briefly today about his PhD work and his transition into industry. So Kamir is originally from Montego Bay, Jamaica. He studied microbiology at the University of Georgia. He went on to Weill Cornell Medicine in New York to do his PhD in computational biology and medicine. There he completed his thesis work in the laboratory of Dr. Imam Hajiraz Zulia. Focusing in cancer genomics, he worked on developing and applying new algorithms to infer into tumor phylogeny and to detect structural variants. On the side, he was still a programmer. He's the founder of the Minds Of Initiative, an online mentorship platform. And actually, early during the pandemic, he co-founded All Clear, a nonprofit organization based in New York City, which developed an app that lets users easily find COVID-19 test sites all across the US, and also gives access to key information such as screening requirements based on an individual's symptoms. Currently, Kamir is a bioinformatics scientist at NVIDIA, where he is focused in genomics and artificial intelligence, and we're looking forward to hearing more about that. So Kamir, thank you very much for taking the time to meet with us, and the floor is yours.
Yeah, no problem. I mean, I can skip all my background slides. No, you kind of hit everything. But yeah, so let me share my screen real quick. Let me know if you see my my screen.
Yep. Good.
Yeah, so so thank you guys for having me. Thanks, Michael, for the invite, and BBSU happy to be here. You know, from what I understand, tried to make this a conversation, but I have a few slides, so I try to not have them be too long, and I'll skip where necessary. And feel free. Can people like chime in during, or is it a thing where I can't hear them? Like, can people ask questions?
Yeah, definitely. Yeah, people feel free to ask questions. Yeah, definitely.
Yeah, cool. So I guess let me just get going. So yeah, so as I was saying, I'm a kid from Mobile. I'm a big LeBron fan. So if you always say a kid from Akron, so I'm a kid from Mobile. I know I lost a couple of people there already who don't like LeBron. A lot of times people think of Mobile, they think of this. My Mobile pretty much look more like this for the most part. So I went to high school in Jamaica. That's me in 7th grade. I got my first lab coat. There I was a part of some science project, and then I graduated. Went all the way up to 13th grade. I studied like natural sciences while I was in high school there, and then kind of decided to pursue my studies here in the U.S. at the University of Georgia. Right, so I studied microbiology and did computer science at the University of Georgia, and I think how I view this, in a lot of ways, I tried to give context as to my thinking throughout the process, how I got into my bioinformatics, and then even in grad school, how I thought through things. So my freshman year of college, I really did not know what I wanted to do. I knew microbiology sounded interesting. I knew I was also into like computer science and IT and that kind of stuff, but I really never saw where the two intersected. Right. For me, I was either going to be a biologist or I was going to be like a software engineer somewhere. So it wasn't until my freshman year of college where a random conversation with a professor, he kind of just told me that that sounds a lot like bioinformatics. That sounds a lot like computational biology. So that kind of led me down the path. I was like, okay, we didn't have a bioinformatics major at that time in undergrad, and a lot of universities now do. But so I figured the best way to kind of get to get experience in that is to get involved in like undergraduate research. So I worked in the lab of John Maurer at the University of Georgia. And I did a lot. That's my first exposure to like multi-sequence alignment. We were looking at this a microorganism called Mycoplasma gallisepticum that was killing a lot of chickens in Georgia. It was a big, I was a part of like the poultry group at UGA and doing a lot of work there. I was able to get a paper out of that, which was super helpful. This is John down here with the with the chicken in the background. I did study abroad, so I went to Oxford and I studied microbiology and genetics while I was at Oxford for a couple months, which was also super interesting and really kind of solidified my interest in pursuing this area. So graduated in 2015 from UGA, clearly proud, classic Caribbean person with the flag always flying. But at that point, I was, kind of solidified on wanting to pursue computational biology. And after going through the graduate school process, ended up going to Weill Cornell Medicine because I was very interested. I did a lot of microbial genetics in undergrad, but I really wanted to get into cancer, explore that space, do something that felt more translational, felt like it applied more to human health. So that's kind of how I end up at Weill Cornell Medicine. And for those who don't know, I was in the Tri-Institute, the Tri-I Computational Biology and Medicine program. So that's a program between Cornell Ithaca, Weill Cornell Medicine, New York City, and then Sloan Kettering Cancer Center. Right. So I joined the lab of Iman Hajrasulia. So he's a computer scientist, by training, but really was big into method development. Really was interested in kind of the metagenomic space, the cancer space, the structural variant space, and that stuff. I obviously did not have any exposure to at the time. So through working with him, I kind of really started exploring those interests and those questions that that exist there. The speaker on the side is me presenting a project at this was Recom in Paris. Back when conferences were fun and all over the place in person. Right. So I really didn't do too much details in terms of projects. I just figured I'd give like a quick overview. So one of the projects that we kind of I ran or got involved with while I was in the lab was this idea of like tumor phylogeny reconstruction with structural variants. Right. So we were building this pipeline and this framework where we feel like we're pretty good at building phylogenies from single nucleotide variants. And then structural variants were always a bit, a lot more complex in terms of how do we estimate their allele frequency and all that. So we really imagine a situation where we could, create something that automatically is able to generate and reconstruct these phylogenies, combining both single nucleotide variants and structural variants by exploiting a lot of these genomic signatures that we have when we see structural variants, right? We see differences in break and coverage. We see different numbers of split read pairs and that kind of stuff. So using all that to really estimate what the allele frequency is, and then using that to kind of reconstruct these tumor lineage trees, right? So we created a tool, we called it Meltos eventually, that was able to not only do variant frequency estimation, but also do this Bayesian clustering of single nucleotide variants and structural variants to then greedily assign structural variants onto a single nucleotide tree, right? And we did we applied it in breast cancer and a few things. I only just put the prostate cancer example here, where we kind of used it to investigate on some of our clinical samples, because we were part of the precision medicine unit at Weill Cornell. So we were looking at actual patients at Cornell and kind of identifying patterns of multi-seeding within certain patients in a lot of their metastatic sites. And that was supported by SNVs and SVs that we were able to show. And, I'm not expecting you to kind of decipher the figures here. They're kind of representative, but essentially, here we have a patient that, multi-region samples taken from both the primary tumor and metastatic sites. And we're able to reconstruct not only a tree based on structural single nucleotide variants, but also, using the tool, be able to place structural variants onto the tree in their relevant location. So this project kind of got me interested in structural variants. And I guess, the point of this is more so to tell the story of kind of my research interests and where they went versus, for this to be a research talk. But so this got me interested in structural variants and how do we call them. So after that, I kind of got, I never worked with link trees before. So we, in the lab, we got our hands on, got interested in, okay, how do link reads come into play? Do they offer advantages over, short reads, from Illumina when it comes to identifying structural variants? So we decided to work on a structural variant caller that exploits linked reads, right? By using the barcodes to really, be able to identify putative SV events that are much larger than any kind of short read caller can call, right? So we're dealing with, greater than 40 kilobase pairs in length in a lot of these, and we're calling, segmental duplications, inversions, translocations, and so on, using this link tree sequencing data. And we really just exploit it. Similarly, how we exploit kind of when you're aligning to a reference, we exploit these the way in which reads orient themselves or map back to the reference in a way that we do not expect. If there was not a SV event, we were able to explore kind of, using this linked read information, the same kind of signatures that we would be looking at in the case of only looking at short reads, right? So that project was called Valor, and it's published as a tool called Valor that you can run on 10x data to identify structural variants. So we did a lot of the method development around structural variants, and then in my experience, you kind of realize how little of the data sets that that are being studied are representative of people that look like me, right? A lot of the genomes that we're analyzing um, do not have people of African ancestries, mainly European, essentially. So I got really curious about just trying to find my way to a project that included looking at maybe structural variation across populations and so on. So I just grabbed a few figures here from one stuff we were working on, where we kind of really started to identify, even at structural variant level, we're seeing like high high variance in the number of structural variant events that we're seeing. So here in the blue, these are the African genomes in this paper, and then similarly from our data set, we can see if you look at Yoruba, Nigerian, and USA African, just the wide range in terms of the variance in the number of SV calls that were done. And in this project, a lot of it is still unpublished yet. There's ongoing work around further characterization of these, because it's very interesting to look within populations what patterns of variation are we observing, and where what are conserved events and mutational signatures within the population context, right? So that's been a big thing for me, and even industry that I'll touch on that later. But even industry, I really look and really follow a lot of companies or efforts that are really thinking about the making sure that the data that they're working on includes is as diverse as I've been lucky to be a part of quite a number of projects while I was in graduate school. There's just a few of them. Some of them also ended up falling in single cell sequencing and so on. And once you're in computational biology, it's easy to kind of like get your hands and stuff all over the place. So sometimes it's a bit hard to stay focused in bioinformatics, depending on the lab. But then we also got exposed to certain deep learning projects, where in the lab we were building deep learning models to essentially classify good quality embryos for IVF, in vitro fertilization, right? So we're able to build out this deep learning model that is able to essentially classify poor, fair, or good embryos for embedding within the patient, right? And this really came from a study that looked at about maybe 10 or 11, I can't remember, 10 or 11 embryologists, and the variance in which they graded the same embryos. So they were all given the same embryos and asked to put a score on it. And you realize, again, with human error, differences in training, one embryologist can classify embryo as good and the other one classify it as poor, which in the clinic and in something as expensive as IVF, you want to really get towards something that is more objective and more close to ground truth as possible. So even that effort, we call this Stork, and it deployed it where you can, any embryologist, the idea is that any embryologist now can essentially use that tool to classify their embryos, even if they don't have, say, someone training that on site, right? And that's the whole point of kind of leveraging deep learning. Let me see. Yeah, I kind of given, and feel free to stop me, or we can go back over anything in more detail. Other activities I was able to take part of while I was in my PhD is I wanted to do an internship. I knew that I was basically angling for industry for the most part. I didn't say that in my my interviews in the beginning, but I knew I was more or less going to go to industry. So I knew I wanted to do an internship. Luckily, my PI was super supportive of that, so I ended up at Natera out in California. We do a lot of prenatal genomics and stuff. And one of their big tools is called Signatera. It's like circulating tumor DNA surveillance tool that they use to detect residual disease, right? So the idea here is that up to like 17 months before any CT scan can detect, a relapse in a patient's, cancer status, they can use ctDNA to determine that. So with them, and I'd never done anything in liquid biopsy before, so that was kind of a new experience working with a lot of their exome data, their single nucleotide variants. A lot of my work there was in refining their error models. So a lot of it involved kind of looking at their error models. How can they be better and kind of remove artifacts and be faster in terms of what they do. And that was kind of my first foray into industry, seeing how industry operates. People work together, that kind of stuff, the pace at which they do science and that kind of stuff. So that was super informative for me. I also did, I essentially volunteered. Like it wasn't paid. I volunteered with a biotech VC firm called KDT Ventures, and I helped them. I basically just helped them do due diligence on companies that they were considering, investing in. So a lot of them, they wanted to see, okay, what is the actual science there? Does it pan out or so on? So they would talk to me. I would have discussions with them about kind of how I felt about the company's deck and their science and underlying technology and where it fits in within the market and that kind of stuff. And that again was a new experience for me. I have no prior experience in doing anything in VC and so on. But that was a very good learning process for me and a good networking opportunity for me as well. As Michael said, around my fourth year in grad school, because I was always involved in mentorship and so on, and seeing kind of holes within career mentorship within my community back in Jamaica, kind of decided to take matters into my own hands and kind of build out a platform, program and the online platform, technology around it to help facilitate the finding of career mentors. And that's definitely was a passion project of mine, and it's kind of grown into, a lot more than I thought it would be at the time. And so that's something I did around my fourth year of graduate school. In terms of kind of frameworks and languages I've touched while in grad school, the usual suspects, Python, R, frameworks like Django, TensorFlow, a little bit of C, C++, Java. A lot of my early stuff in grad school was Java, just because of the way the code base I inherited. So I'm about to, my graduation is technically, I defended last December, but my graduation is in a few weeks. So, this is me, this picture on the left is me agonizing about something. I just pulled it in my early years of grad school. So I'm super happy to, to be done. And then now I work with NVIDIA, right? So NVIDIA is a big tech company. A lot of people, when I say that, they're really confused because they're like, they make graphics cards, right? Like, I thought you did biology, and so on. But NVIDIA, I was not considered NVIDIA at all in terms of my master plan. Companies I was looking at, companies I was talking to, companies I almost signed. NVIDIA kind of really came, in my radar as an option very last minute, and I can dive more into that if people want to know. But I am now a bioinformatics scientist in AI with NVIDIA, and they're launching, or they've been working in this whole realm of DNA RNA sequencing technology. And a lot of people who don't know, they have a whole health department called Clara, right? So Clara, we have medical imaging, we have drug discovery, we have genomics, which is the team I mainly work on, and there's a few others. They have like a smart hospital area within NVIDIA, and we do a lot of the similar things that I've been doing in graduate school. We're building out these methods and actually doing research into ways in which we can use AI, deep learning, and or just accelerated GPUs to be better, more accurate at variant calling, do clinical scale things, which is kind of why I'm there and why they brought me on to really help out with those efforts, right? And a lot of people don't realize a lot of these tech companies are getting into the healthcare space. Amazon, a lot of companies, a lot of industry companies run their pipelines in AWS cloud. So Amazon has its own bioinformatics group within Amazon. Google, a lot of Google AI, and so the deep variant. I don't know if some of you guys maybe use that variant caller, but that's again out of Google's research group. So that's kind of where I kind of that's what I have in terms of slides into of my background. I kind of threw these topics up there as topics I imagine when I just finished graduate school, so I'm not that far removed. That as a graduate school student might be stuff I want to discuss, but happy to kind of let you guys lead it or ask questions or so on. So that's it for me.
All right. Yeah, thank you. Thank you very much. That was cool. That was interesting.
No problem.
Are there any questions from anybody in the audience? If not yet, I have a couple questions. So yeah, so you mentioned, because I was wondering, so in your current position, are you using a lot of the tools that you used in your PhD in your current position, or is there's also quite a bit that you're quite a bit of new things that you have to learn, right?
Yeah, I
Yeah,
mean,
you did mention that. Yeah, yeah.
the answer is both. So
Mm.
a lot of it is there's a lot of it that's going to fall within stuff I've done before. So working with variant calling, annotation, that kind of stuff. They use Python a lot, PyTorch for deep learning, things that I've seen before and touched on before. But there's also a lot of stuff I haven't done before. They because they work in this accelerated space. They do a lot more. They're a lot deeper in like HP, high performance computing, C++, acceleration of tools that I haven't done. And to be quite frank, in a PhD, you're just trying to get stuff to work. Like you really don't, you don't really care about, you're not really paying attention as much to kind of these metrics, runtime and looking at competitors and making sure you're just as accurate or more accurate, but also faster and that kind of stuff. And at a company like NVIDIA, that now becomes something that I have to keep in the back of my head now. The equation changes in terms of what is success, in a space like that. But that stuff you learn as you come on board. But I think, I felt like my PhD prepared me, pretty well to at least get going and have those discussions and learn.
So there's a couple questions in the chat that I can read out to you. One is, when you were deciding to go into industry, what were the main things you balanced when considering industry over academia? And there's a second part. Did you consider diversity and inclusion when deciding on a company? If so, how did this affect your final decision?
Yeah, good question. So my decision to go industry of academia, I never saw myself as a professor or PI for some reason. That was something I was open to changing during my time in graduate school. But I think seeing the passion with which my PI wrote grants, I was just like, that's not me. I don't see that being a part of my thing where like he was just so always happy, like, hey guys, it's grant. But I don't know, it's hard to describe, but I witnessed it first and I was like, I don't have that yearning, and a lot of your success in academia, it's like your ability to get grants and want to get grants. And a lot of the arguments that I used to hear about why you stay in academia over industry, a lot of them feel. So a lot of people would say, oh, go to academia to do what you want to do, like research what you want to do and be able to do that. But at the end of the day, funding is so political where you can't really do anything after. You have to become, at certainly, a George Church where you can just write any kind of grant and get whatever money you want. So that wasn't, that didn't factor in, or being the kind of openness that they talk about academia with. I think a lot of startup companies, especially biotech, because of that tech culture, you now get a lot of that openness, that freedom, that openness to communicate with people, even your peers. Like a lot of it is so flat now in biotech where you don't feel like it's super hierarchical and so on. So I think for me, it was just wanting to be in a space where I didn't feel like I had to write grants to be successful, and we could move quickly, and didn't need a lot of bureaucracy, in the academic institution to kind of go after stuff. And it just seemed more exciting to me as well, like just from my internships and people I knew in industry and so on. But yeah, that was for me. I have a lot of friends who love being in academia. And what was the second? Oh, diversity.
Right.
I consider diversity. I wanted to, and I think I had reached a point, especially being at Weill Cornell, where I was one of two. Like, at some point I just stopped. I just didn't think, okay, in any company I go within, kind of who's doing computational biology and so on, my bar for like, oh, I want them to be super diverse or so on. I kind of lost hope in a lot of regards to that. So, but I think one of the things what I was looking at and why I, got into some of the few companies I did, like, NVIDIA, for example, I was able to meet a lot of the people that they have, not necessarily in the genomics field, in the genomics group, like, that's not necessarily super diverse the way I would want it to, but the overall company, they have kind of, the Black NVIDIA network, and I've been able to meet a bunch of people in that group before deciding to join and kind of getting their feel of what their experience has been at NVIDIA and the kind of efforts that NVIDIA is doing. And I really love the fact that NVIDIA supported them. Like, they have so many programs now that they're doing, in parts of Africa and Latin America and so on, that they kind of empower the Black NVIDIA network to, go and take NVIDIA money and do, these kind of community engagement and projects which, really, aligns with a lot of my interests as well. But the reality of it, when I was looking around, it was a lot about, the kind of work that they're doing, where they're doing it at, because I didn't want to leave New York at the time. I worked in California and decided I didn't want to go back. I didn't want to go back to California. Of course, the pandemic, everybody's remote. But yeah, so a lot of those things kind of came first, and then I kind of was like, okay, if I can get a company or someone that is diverse, and I see a lot of people, that would be icing on the cake for sure.
So there's a few questions in the chat. The next one is, what has been the biggest challenge that you have faced in your transition from academia to industry?
Academia to industry. I think it's probably the pace. The pace is much faster. Much faster. I think I was so used to the regular cadence of, okay, me and my peer have 1 week meetings, meetings once a week. And that's kind of how, every time we discuss, okay, we're going to do this. And in my mind, I'm like, okay, I have to get this done by next week when we have a meeting or so on. Industry, at least in my experience, because different companies have different cultures, but it's a bit faster than that. So when you meet, it's like, oh yeah, when you think you can get this done by, or in your mind you're thinking, okay, next week is our next meeting. No, your next meeting might be tomorrow, might be 2 days after that. So it depends, and that's not always the case, but the pace and with which you do things is faster. I think another challenging transition is just, for me personally, I'm the type to get an idea and I immediately jump into it. Let's go. Let me drive a proof of concept or something like that. But at NVIDIA specifically, are big companies. There's so much more planning that goes into it before they even want you to step a foot in that direction, because it's all about making sure it's worth our time, right? Worth our investment and so on. So there's so many discussions that go on, just flushing it out. Like, even if this is the idea, okay, who's in the space? What can we do? What would you need to learn, or what kind of talent or what kind of expertise would we need that might not be on the team yet? Just flushing out to the umpteenth degree before we say, okay, boom, let's do it. Versus, at least in my lab, we have an idea, we go try to see if we can get some early indicators and so on. And then startup would probably be more similar to that startup biotech, where they kind of work faster than like a big tech or a big biotech company. So there's always these kind of small differences, and that is an adjustment to me. I think on the other side of it, I really enjoy having a whole group of people like all working in one direction in the industry, where I don't feel, I think in academia, you're kind of siloed, right? So you have your project, from the beginning to the end, you might have collaborations here or there, but you're really, it's on you to bring that to fruition. Versus, in my experience in industry, we're all pushing in the same direction, and it's nothing for, if you're stuck here, you can't code up this thing here or whatever, it's quick to go tap into somebody, and you have what we call these peer coding sessions, where you're just coding together at the same time and working through the problem. Or if you're not that strong in statistics, or grab the statistics guy, and he takes over for the 2 days that's necessary for those things. So you feel less alone, I think, which has been great for me. Just on the inverse of what's the hardest. Trying to think of what other adjustments might be. And I'm also I'm also a couple months into it, so it's not like I'm, years into industry and so on. So I'm still going through those pains and that adjustment. But yeah.
So we have another question in the chat. It says, "Hey, Dr. Ricketts," or from Eric Cheek. "Hey, Dr. Ricketts, thank you for your presentation. I would like to know how your interview process at NVIDIA went. Could you also speak on the overall job market coming from a bioinformatics background?" He is currently studying signal and image processing with a research focus in medical imaging, but is possibly interested in switching to big tech.
Gotcha. But from a job market perspective, oh my God, we are in the right field. Like I really didn't appreciate. I was told a lot in grad school, but as soon as I clicked that button on LinkedIn that said I'm on the job market now, yeah, there's a lot of opportunities out there, and for the most part, you'll be picking and choosing in this area, right? And unless you want to go somewhere specific and kind of out there, like you want a job in Idaho or something, then it might be more uphill battle. But to speak to the interview process, so generally speaking, because I've spoken with a lot of biotech companies, interview is really laid back. And this, I'm not talking about NVIDIA, I'm just talking about biotech mainly, where a lot of it is just about your research. It's like, what did you do during grad school? You kind of tell them, what do you want to do next? And you kind of share, they tell you about the company, where it is. And they're really just focusing, they just want to see where your interests are and if they align with the company and get a sense of you as a person. Like biotech companies, especially startups, in my experience, they want to know what kind of data sets, how many different types of skills that you have. So they're lucky you're like 2 hires in one if you've done AI and bioinformatics, genomic stuff or so on. But it's generally just a conversation about your experiences. Now, NVIDIA, on the other hand, which I learned the hard way because I didn't realize this, they're a tech company. So they interview like a tech company, even though you're coming into this kind of genomics, biotech, sub arm within the company. And I didn't realize that. And to be honest, because I didn't intend to go, somebody reached out from NVIDIA to me, and I was like, sure, I'll take the conversation. They're like, oh, you're open to having a conversation. I'm like, sure, I'm not going to turn that down. And then, I blink and all of a sudden I'm getting emails like, okay, you're scheduled for 6 interviews on Tuesday. They'll start at 11 a.m. and go on to, 6 1-hour interviews and go on till the evening. Only one day, your questions will consist of bioinformatics and Python questions and deep learning. Good luck. And I was like, wait, like what? What is this? I'm used to just talking about my, my little tools that I built and my cancer research and that's the interview. But no, so that was my first time really, I had to code live. So they join the group Zoom session, they send you a link on Google Docs with a prompt, find all substrings within this sequence, or write out a naive aligner for these 2 sequences or that kind of stuff. And you're just coding and they're like, oh, talk me through what you're thinking as you code and all that. And of course, in those moments, you're like, oh, is this how you even write a for loop? You're second guessing everything. So that was a new experience and a stressful experience for me. And because of how the interview is very much about your technical ability. So every interview was really just, okay, say you're training this model and you don't have access to XYZ type of data set. How would you get around that? Say you're on a project where you have access to tumor, to whole genome, short read, sequencing of the tumor, but no match normal. How would you, take out as many, possible germline variants? Like just all these hypothetical situations that really just test, your ability to kind of, formulate your ideas, to plan, to think through a problem, that kind of stuff, which you don't really get in biotech, in my experience. Is very much a conversation. So, when you are considering these kind of tech companies, keep that in mind, where it's going, you're probably going to interview more along, more similarly to your software engineer friends in terms of the style of interview than your, friends who are going into the biotech space for sure. But, it's doable. It's doable. I think, did she have another part to her question? I can't see the question, so.
I think, yeah, there's one more question. I think that was the whole question. There's one more question from Kathy Smith. So how do you balance your time commitments between your own research and your mentorship platform?
Good question. I think it's a zero-sum game. So time I spend doing other stuff, could have been time I spent on research or so on. So for some people, science might be the end all be all. That's all they want to do, and that they don't want, and that's great. For me, I have kind of other aspirations. So I have to be resolved and accept the fact that anytime I give to any of these other passions is time I could have spent being even more of an expert as a scientist and rising my ranks. But I'm at the stage where that's not, in terms of my value structure, that's not what I need to drive. So generally, especially now that I'm working, it's just it's easier now. I think as graduate students, it's hard to even imagine having time for other stuff because a lot of your work just take up so much of your time. But one thing I appreciate about industry is that they really respect the fact that you have a life. At least in my experience, again, let me just add that disclaimer. But so like even in starting this job, there are a lot of times where I was like, oh yeah, I'll try to read out a couple papers on that over the weekend, so I can ready for the meeting on Tuesday. And they're like, yeah, for the weekend, like what are you talking about? Like that's a weekend, don't do that. Like do it next week or and for me is I'm trying to signal that I'm trying to get going as quickly as possible and so on. They're like, yo, chill, like it's a weekend, relax. It's 5 o'clock, they have like no meetings on Friday, policies and stuff like that, which I couldn't imagine that in graduate school. Like, weekend work is regular, evening work, homework, that's just the nature of the game. So for me, that's been beneficial to me. But I think it's just timing, because I would never have done something like launching this mentorship program during my second year of graduate school, during my third year of graduate school. You have to know where you're at and what you can allot, right? Like I had to make sure I passed my, we call them the ACE, the qualifying exams and that kind of stuff, have to get somewhat of a footing, get my publication out the door, all that kind of stuff had to have happened before I was in a position where I'm saying, okay, I'm kind of, I've kind of hit, my publication already published, publication coming out, kind of cruising more or less towards my defense. I know what I'm doing, I know what I need to do. I can carve out time here and there, this weekend here and there, because I really care about working on this project. And to be honest, it took a lot more time. Like working on this effort took way more time that I thought it was gonna be like a little side thing. We mentor 1 or 2 kids and so on, and it kind of grew into this thing that took up so much more time. But I really wanted to do it, so I found a way to do it. But I was at the right stage of graduate school to be able to pull that off, right? And I think it also helped me also because I think when we kind of get all caught up in our research and science is all we do, anytime we take those L's, that inevitably come research is earth shattering, because like to us, we are scientists, this is what I do. So I took an L in this is tough. And then the moment, I found something else that was, another part of me and something I felt, passionate about, and something I would do full time. Like if you told me science is gone tomorrow, I'll be happy, not full time. Like even the L's I took in research kind of had less of a blow because, the science wasn't all that I did. So I always kind of encourage, it doesn't have to be launching one mentorship program, but like finding stuff that represent another side of you and stuff that you care about and so on is definitely not something to make grad school take away from you. Try your best to hold on to them and do them as best as possible. But yeah, kind of a long answer to that question, but yeah, sorry.
That was great. I had a question as well. So you noted a lot of adjustments that had to be made, going from PhD to a career in industry. And I'm just wondering what aspects of your PhD experience do you think best prepared you for industry?
Let me see. So there are a couple of different things. So I think from a networking perspective, the conferences that I went to during my PhD, I think conferences are still undervalued by some PIs. I've met students who are in labs that, their PIs don't want to go to conferences and stuff like that. But if you want to go into industry specific and also academia too, because I've gotten postdoc offers at conferences kind of out of the blue, is just, being able to, to communicate when you're presenting, presenting your research, doing that over and over again, you get so much better at communicating, which is super helpful in industry, and also opens a lot more doors to you within the company, where you're not just somebody who can do this one thing, but they can see you in management and all these kind of things. But if you want to go into industry, that's where you meet a lot of these companies, meet people from the companies. I remember, I was at ASHG, I think it was, and after one of the evenings, a bunch of people just randomly going out to different bars, and I think it was in Houston, and so on. I spent the whole night there drinking and talking with these people, and didn't know where they were from, or whatever. And it was at the end of the night where I realized like two of the people there were like CEOs of like biotech companies out in California and so on, and like we've kept in touch since then, in a way. So I think the conferences within grad school, unfortunately, a lot of them remote right now, are super useful if you take full advantage of them. Go there, be present, give a post if you can. I know it's annoying. Like I was that student who like, yo, I really don't want to give a post or a presentation sometimes. I know the feeling, but if you want to go in industry, I can't stress enough how useful it is to be in those spaces. And also for posts, people get postdocs. A lot of people, friends of mine, I did as well. I gave a presentation, and then somebody from the Netherlands came up, was like, hey, we're doing this X, Y, and Z. If you're interested in a postdoc, after you finish, come let me know. So definitely focus on that. If you can do an internship, that's great. And then within the PhD itself, now projects that you can lead, like try to have a project, because in bioinformatics, it's easy just to be like a collaborator where this wet lab just throws some data your way, you analyze and send it back to them, and that's kind of what your PhD has evolved into. I've seen, right? So I think in terms of preparing for industry just built to really value people who can, and not just industry, but industry in this context, really value people who will take the project and can be able to flesh it out from a competitive analysis of the market. What will it take to get us from here to there? Because especially in startups, that after the higher ups don't know really the expertise that it takes, or what it takes to do, or the kind of infrastructure they need to build out to be able to do these things. So any situation in grad school where you can be the person in charge of that project, really, and I mean that's what thesis is supposed to be, but a lot of times in reality, you're just kind of doing a lot of collaborations and not really owning a person. So I think being able to do stuff like that really prepare you to do industry, and then not shying away from the tough questions. I think in grad school, and I similarly, I used to hate giving presentations where I know my data kind of finicky. Like I know the data not all the way there, and I know as soon as that slide come up, there's gonna be a million hand raised in the air, and it's like, something look kind of fishy there. But people in industry, like everything has a dollar value. All the time you spend on projects, come at a cost and so on. So industry, a lot of those conversations, they try to have it early. A lot of people are frank, and I think the more you're used to just dealing with those tough questions or asking those tough questions and that kind of stuff, is beneficial for you in being successful in industry. But and then of course from a technical aspect, anytime if you can do anything in deep learning while you're here, I mean, depending on what your general interests are. But so many companies, companies I know that were founded in kind of diagnostics and just kind of genomics, when I speak to people at those companies, they're trying to hit their head on the wall, trying to find a way to like incorporate deep learning in some way. They don't even know what they want to use it for, but they don't know that they need to go in that direction. So if you in your PhD journey can touch on a project that has anything to do with that, or just in a personal, ideally a project, but in a personal time, get acquainted with stuff around AI, that's great. Like I didn't get to do enough of it. I wish I did more, but that's kind of one of the reasons I went to NVIDIA is somewhere I could get a lot more of that expertise and so on. But yeah, a lot, especially when you're going into biotech and tech, your ability, your coding ability, all those kind of things is useful. I think graduate students, it's not emphasized, but as much as we can even learn how to code from a, like software engineers. So, understanding what agile development mean and that kind of stuff around that is a plus. It's not something that you have to get in the industry, but all these things always differentiate yourself because, instead of you having to learn it when you get into the job, you understand how to truly use, Jira, like, these project management platforms where they're putting up tickets or tasks and just, all that kind of stuff. And even me, like I didn't fully know I thought I knew how to use GitHub until you learn how to use GitHub and realize there's so many so many ways, become more of a power user of GitHub. So all those things I think are useful in a PhD. But yeah, getting a project that you can own and really flush out is the best. And trying to get a sample of deep learning will make it way more competitive, because it's a hard thing, and it's going to be a hard thing for a while.
Yeah, thank you. Actually, a quick follow-up on that last piece. Like inevitably, of course, there will be like, learning curve stepping into industry. Like you said, maybe you haven't been as immersed in a certain area as much as you had hoped.
Yeah.
So I'm wondering, like, how forgiving are they in industry? Like once you get a position to learn and grow in that space? Because I remember you mentioned a little bit earlier, when you start on a project, they evaluate what expertise is missing from the team that we can get elsewhere. Do they allow people already on the team to kind of, shift their interests and learn and grow?
Yeah, and when I say that, it's not in the case where like, oh, this expertise is missing, you're out, let's get this person in. But yeah, so and it changes when you're in a startup environment versus kind of a big company that has the leeway, a lot of leeway to do what they want. In a startup environment, no, that leeway shrinks. That patience shrinks a little bit, because a lot of biotech companies, they have like a runway, in terms of like how much money they have to burn for maybe 3 years if they're very early, and so on. So a lot of those decisions they try to make quickly, and you might be the only computational person on the team. A few of my options when I was coming out, I would have been their first computational hire. So in that case, there's no, you'd have to go figure out how to learn everything I own. There's no within the company growing in terms of your technical expertise from people who are already there. So that is something to consider. But generally, yes, they do make room. Like at NVIDIA, there's a ton of room to grow. And if you don't have practical expertise, they kind of do everything possible to help you get there, right? So there, we've been talking about doing these deep learning rotations within the team, where even if your project, right now you don't do anything deep learning or AI, you can get, for 3 months, you leave us on the genomic side and, go do maybe an AI project in drug discovery with that team and kind of learn, or you go work on autonomous driving with the team at NVIDIA who are doing that, or you go work on their AI for conversational speech and so on and come back. So I think a lot of companies in the industry try to, once you get in the door, they want you to grow in kind of all aspects, and a lot of them, they do it different ways, but they try to get the idea from you. Okay, what do you want to do? Are you somebody who see yourself going into management? So they want you, want to grow you, and they assess you based on what you tell them you want to become, right? So if you want to become a manager and all that kind of stuff, then they want to, they're really going to try to cultivate and nurture you to become a lead and handle project management skills and all that kind of stuff. Versus if you want to become senior the engineer or senior scientist or whatever, it might be a different track. But they're generally forgiving, and they have so many people, again, at a company like NVIDIA and other big companies, there's so many people with so many other skill sets from yours, where if you get stuck or feel is not something that I've seen where it's like, oh wow, you really can't do this, like, come on. No, it's more, okay, who on the team can chip in here, help you, guide you, and so on. Because at the end of the day, everybody kind of pushing in the same direction. And of course, unfortunately, cultures are different in some places. So and then even within the same company, if it's big enough, team cultures are different. But generally speaking, there's definitely a lot of room to improve when you go in the industry.
All right. If there are any more questions, feel free. Unmute yourself. Let's see. Okay. Well, oh.
Yeah, I mean, I just want to just make a note of it, because in getting into industry, a lot of times some people kind of rely on, okay, I'll go on the job boards, I'll find what posts are there and apply and so on. But I would recommend not to rely on that approach. A lot of the opportunities I had, a lot of the conversations, after I was already, offered the position or even the internship that I accepted, they were like, okay, you have to wait a month because we have to put it on our page, because that's the law. And then, we'll take it down, after a week. Because so technically they're posting this job that I already accepted and so on. So, I just want to make that clear. And I mean, people still, people of course get jobs that way sometimes, but definitely leverage LinkedIn, something I did a lot, if I'm in a new city, even when I was doing my internship in California, your PI has such a huge network, use it, take full advantage of it. So I'm in California, text my PI, I was like, yo, I'm out here, like, who do you know out here? Let me set up a coffee meeting while I'm out here. And they are like randomly messaging people on LinkedIn. Sometimes they might not reply, sometimes they do, but trying your best to kind of meet people, at conferences, that's a great place. And then, for me, one of my motivations for even volunteering with a biotech VC firm is that instead of me having to network with every single CEO, I network with the one group that gives 50 of them money and invest in 50 of them. So when I was on the job market, I hit him up and he sent me, a bunch of companies that were looking and, put me in touch with their people and, I was talking with them. So, stuff like that is something, not everybody feel like they're good at networking and all that kind of stuff, and they can feel cringy, awkward, whatever you might call it, but it's super valuable and save you a lot of time because, with people who you develop relationships with, those conversations, become super, super easy when you're looking for a job and they know you. And then at the end of the day, if people like you as a person and like believe what you do, I kind of make your life easier. So that'll just be kind of my last thing, is just emphasize how much that is helpful, in networking and all that good stuff.
All right, I have a couple more questions and then I think we'll wrap up the meeting. But so another industry question. So if we want to go into industry, how important is the internship? Because it seems like the other things that you mentioned, like owning your project, being innovative in your project, those seem to be more important. But how important is the industry? Because it might be hard for some students to take the time, maybe.
Yeah.
Depend. Yeah.
I don't think it's something that makes or breaks. It definitely doesn't break a case. Then I think it's something that for you personally, figuring out this is something you really like, this kind of environment that you can do science in and so on, I think is super important. You just, before making that decision, be in that environment. But when assessing, say, your resume or so on, it's nice to have, but I think a lot of them, at least in my conversations, I understand that PhD students, sometimes you focus on PhD, and not all PIs, are supportive of internships and you leaving and so on. So I wouldn't say something to be super, feel down about, like, oh, I can't get that internship in before going on job market, so that will really hinder me. And the reality, there's so many opportunities out there, Michael. So, there might be a company where, that team really values internships, and, that might be a knock on your application, but there's like 15 other ones that you can go and apply to, and they might not have the same view. So I really enjoyed mine, and it really helped solidify my decision process, and especially for those who might be on the edge, academia versus industry, it can be super helpful if you can pull it off. But yeah.
And just one more question. So say if we wanted to apply a specific tool like deep learning to our own research, so, in preparation for industry, for example, in your experience, what are the steps in learning like a new tool and then applying it,
So just applying deep learning overall, like just trying to find a way to incorporate it. You mean?
Yeah, or that, and then also say like a new tool that in general, the steps of learning something new and then applying it.
Well, I guess generally in my experience, if I want to try to get deeper involved in my project or so on, my first move is just to tap into somebody I know that's what they do, and say, hey, this is the kind of stuff I'm doing, this kind of data, because deep learning is all about data that you have available. So this kind of data I'm working with, this is what I'm trying to accomplish, right? And then here and there input in terms of like that kind of data, because it might be cool to like hear them construct, say, a project like, okay, I think if you train, this ResNet model, that can get you to that end goal without having to, kind of, do the classic kind of logical programming. But but you need so many data points when doing deep learning, it might just not be feasible, right? So generally in terms of like how do I bring in deep learning in my project or so on, the easiest way is just talk to somebody. If you have somebody in the lab, somebody in the program who does that kind of stuff, getting with them and just sitting down with them and saying like, hey, this is the lay of the land. This is what I'm working on. I'm looking for opportunities where deep learning might make my life better, get me to the end goal faster. Where do you see separating? The other way is for you to then, outside of that, is for you to then try to like look at the landscape of deep learning, the kind of projects that people are doing in deep learning, and then try to like map that to what you're doing, which is is the harder. If you're not somebody in deep learning, that's going to take a lot a lot longer in terms of time. So I definitely think the easiest way is just talk with somebody who can just throw ideas. All if they end up not being feasible or something, just start thinking how can you do that? Because in a lot of ways too, I think we use deep learning a lot of times when we don't need to. So it's not always beneficial. But from a learning standpoint, I get that part don't matter. Like it's an excuse to learn it and go through the entire process. And then your second question was like use a new tool. That kind of stuff.
So like a similar question. You basically answered it really.
Yeah. Because tools for me is different. It's like that I just like jump on the GitHub, find the README, and then spend the next half a day trying to install it. You know what I mean? And then trying to make it work. But, yeah.
All right. Well, thank you very much, Kamir. Thanks for coming. Thanks for taking the time. We really appreciate it. I think we all found it really informative for sure. So thanks again.
Yeah, and feel free. I think I put my my link. Oh, you emailed up my LinkedIn too. But yeah, feel free to reach out, connect with me, shoot me questions. Happy to kind of discuss further and talk about other options.
All right. Gabrielle, you have some announcements?
Yeah, so we won't keep you all here too much longer, but for those who are interested in, continuing to engage with BVSU in the future, just a few logistics to go over. So in our first meeting a few weeks ago, we had discussed building a repository of data analysis resources and best practices. So we've put together a shared Google Drive that we've already started to populate with some of those resources. So stuff pertaining to bioinformatic analyses in several different programming languages, as well as resources specific to bioinformatics courses offered here at the university, and some more things. So we encourage you guys to add freely to that as well. And if you're interested in gaining access to that drive, we ask that you please join our Slack page. I'll go ahead and link that in the chat here. So go ahead and join that. That's primarily where we'll try to send you guys information. Additionally, in our last meeting, the idea was brought up to come up with a project that we can all work on collectively, or a series of projects, specifically as a way for students who are new to programming or who are coming from disciplines outside of bioinformatics to see how we can apply programming in ways relevant to their research needs or interests. So currently, myself and the other eBoard members were putting together a list of project ideas that we'll send out as a poll on the Slack for you guys to vote on. And we'll also give you guys the opportunity to propose project ideas of your own as well. This is meant to be kind of like introductory kind of project. We're still figuring out what the format would be, but we hope that think of it as an engaging exercise. It'll be a reasonable time commitment. And so we'll hope to get that up and running pretty soon. And then lastly, just stay tuned for future events. We plan to put together a social event, likely a picnic or barbecue, now that it's warming up outside, and potentially in collaboration with some other STEM groups on campus. And we'll also look to host a couple of coding workshops and other wonderful seminar talks like this. So more details to come, and we'll keep you guys posted.
And Kamir, feel free to fly to Michigan for our barbecue.
Hey, I'm outside this summer, so I'll go to Michigan.
All right. Well, if there are no questions, then did someone say something? Or?
There was some comments in the chat. Yeah, thank you guys so much for coming. Appreciate it. And thank you again, Dr. Ricketts, for sharing with us. You
Yeah,
had some really great advice, and
it was great. And I saw somebody just mentioned that, they're feeling lost in the middle of the degree. And that's definitely, that's universal. That's something that happens. And when I was there, I was like, okay, there's no way I'm going to get out of this. But it's just something that happens in your gut. At some point, it just like clicks and you're able to like, escape it. So just keep trying to laugh.
yeah.
All right, thank you.
All right. Take
All
care.
right, guys. All right, see you.
Bye, everyone.